just a reminder on what math operation you're going to do to solve for the missing piece of your trig ratio, depending on what that missing piece is. So there's always three parts. You're going to have your numerator and denominator. Those are the side lengths. And then you're going to have an angle measure. Okay, if it's the angle measure that's missing, you have to do inverse trig. If it's one of the sides, you're just going to multiply or divide. If it's the denominator that's missing, we divide. If it's the numerator that's missing, we multiply. Okay, so you can refer back to that table as you're going through your trig problems if you get it set up and forget what to do from there. Now, these are very similar to what we've been working on. It's just the triangle's not drawn and labeled and set up, ready to go. You have to interpret the word problem. Okay, we have to, and so that we can apply our trig to the real world problem. Okay, so for this first one, it says that there's a ladder, an 8-foot ladder leaning against a building at a 32-degree angle with the ground. And it says how far away from the building is the base of the ladder. Okay, so hopefully y'all can interpret, I've gone ahead and drawn the triangle. What part of this triangle is the ladder? The hypotenuse. Okay, the ladder leans, right? Okay, and so what is this vertical piece representing? This vertical leg? Yeah, that's the wall, that's the building. And yeah, up here, this is how high up the building the ladder is hitting. Okay, so this is the building. Okay, and then what's this horizontal piece? The ground. Okay, you're not going to have to label like this, everyone. I'm just, for the sake of our first problem, making sure everybody understands that. All right, so it's an 8-foot ladder. Okay, so the hypotenuse is 8 here. Okay, it leans against a building at a 32-degree angle with the ground. So the ladder and the ground make a 32-degree angle. Okay, how far away from the building is the base of the ladder? Well, the base of the ladder is here, the bottom of the ladder. Here's the building here. They're asking how far apart are those? So they're looking for this horizontal leg down here. So I'm going to label from the 32-degree angle, opposite, adjacent, and hypotenuse. They gave us the hypotenuse, and they're asking us to find the adjacent. That's the one I highlighted. So what trig function would you use if you're using A and H? Okay, if you need to, we can put up here under our table, we can put our reminder of SOHCAHTOA or whatever memory trick you chose or you prefer. Okay, so A and H, that's cosine. So we're going to set up cosine of theta is A over H. You plug in what you know, which I know the angle is 32 degrees. I don't know the adjacent side. I know the hypotenuse is 8. So here my numerator is missing. What does it say here to do when the numerator is missing? Yeah, you just multiply. So we're going to do 8 times cosine of 32. You just multiply that 8 over to the other side to solve for x. So 8 cosine of 32. I'm going to use the Desmos scientific calculator here because that's what y'all are going to have on the tests and quizzes when you're in Aware, the built-in calculator. So here's what your keyboard on the Desmos scientific looks like. So it's this toggle here that you need to make sure is in degree mode. You should see DEG. If it looks like this and RAD shows, you're in radian mode and you're going to get your answers wrong when you use sine, cosine, and tangent. Okay, so we want to make sure we're in degree mode and it's 8 cosine of 32. We're going to get in the habit of rounding to thousandths. That is 3 places after the decimal, but you have to look at the 4th place to see if it rounds up or stays as is. So does this one round up or stay as is? Yeah, so this is 6.784 approximately. Now, application problems, these are real world problems. This represents something in this scenario. What does this represent? What are the units? Well, what is this a measure? What type of measurement is this?
Feet.
This is in feet because it says the ladder was the 8-foot ladder. Okay, so that was measured in feet. So this is in feet. So the base of the ladder is 6.784 feet from the building. That's how far away the bottom of the ladder is to the building. So far, so good? All right. Now, before we jump into another question, just want to introduce some vocabulary phrases that you need to know. Okay, they're highlighted there. It's angle of elevation and angle of depression. Okay, elevate and depress, those are opposites, aren't they? Elevate means to go up, depress means to go down. Okay, so in these scenarios, this graphic here is showing you an airplane flying. So here's a horizontal, that's the path of the airplane. Okay, and here's a horizontal where this guy's line, his vision, if he's looking straight, it creates this horizontal. Now, when he tilts his head up to look up at the plane, okay, this is called the angle of elevation. It's from the horizontal up. Elevates go up. So from the horizontal up, that's your angle of elevation. Now, from the airplane going down to that line of sight to the guy on the ground, that's depress. Okay, it's from the horizontal going down. So it's the angle of depression. Okay, so both are measured from a horizontal. Okay, that part's very important. Okay, so from a horizontal line. Okay, if you're going up from the horizontal, you're creating the angle of elevation, down, angle of depression. Okay, you may remember in geometry. So if we have two horizontal lines, those are parallel to each other, aren't they? Y'all remember parallel lines and transversals from geometry? Created these two intersections. There's 4 angles at each. So you have 8 angles in this image. And y'all learned all about the different relationships between those 8 angles. Do y'all kind of recall that? Okay, if we look at the angle of depression and angle of elevation, that corresponds over here. This is the angle of depression. And this one here on the right, that's the angle of elevation. Okay. Do y'all remember from geometry what that relationship between those two angles is?
Was it alternate too?
Those are alternate interior angles. And what does that mean? They're congruent. So it says down here, they're alternate interior angles, but that means that they are congruent. Remember, you could have picked any 2 of the 8 angles created here, and they would either be congruent or supplementary. They're either the same as each other or they add to 180. Okay, so in this case, the alternate interior, they're on alternate sides of the transversal and they're in between the parallel lines, so they're interior. So alternate interior angles are congruent. So when you draw your triangle for whatever your situation is in your problem, sometimes the angle of depression or the angle of elevation may end up being outside the triangle that you drew. So like if I drew the height of the airplane here, the altitude here, and then I had this drawn as my triangle, and it said something about angle of depression, somebody might be like, that's not even in my triangle. How am I supposed to find that? Well, it's equal to this angle of elevation in your triangle, right? So you could find that angle, and then the angle of depression would be the same. Does that make sense? So you need to know that those are congruent to each other. All right. In this next example, it says that a surveyor is standing 115 feet from the base of the Washington Monument. He measures the angle of elevation to the top of the monument to be 78.3 degrees. How tall is the Washington Monument? Okay, so what side of this triangle is the Washington Monument? The vertical one, right? Okay, so Washington Monument going straight up and down here. That's what we're looking for, is that height there, that length of that side. It says there's a surveyor standing 100 feet, 115 feet away from the base. So here's the base. So 115 feet, there's a guy standing over here. So this is 115. Okay, and from where that guy is standing, he measures the angle of elevation. So that means from the horizontal up, okay, to the top of the Washington Monument, that angle created is 78.3 degrees. Okay, so this is what we're given. So I'm going to label my triangle from that 78.3 degree angle. I'm going to say this is the opposite side. You know, across from the 90 is the hypotenuse, and this is the adjacent side. So they're asking us to find the opposite side when we've been given the adjacent. What trig function puts O and A together? Good, tangent. So there's the tangent trig function. We're going to plug in what we know. We know that the angle is 78.3. We know the adjacent is 115. So our missing piece, again, is the numerator. We said when the numerator is missing, we multiply. So I just need to do in my calculator 115 times tangent of 78.3. So 115 tangent of 78.3. Okay, if I'm going to thousandths, what will this come out to? 314. Good, because I look at the next value, which is a 9, it rounds that 3 up. So 555.314. And what is that telling us? What is 555.314? In feet. So the Washington Monument is approximately 555.314 feet tall. Everybody feel okay about that one? All right. Let's try this one. I've got a little more sketched for this picture to help interpret the problem, because that tends to be an issue for some people, is understanding what they mean. So this says that there's a lighthouse 200 yards from a bike path along the edge of a lake. That is a typo. Along the edge of a lake. Okay, so I've drawn a lake. And here's a bike path going along the edge of the lake. And then there's a lighthouse. The direct distance is 200 yards. Okay, the most direct distance, the shortest distance would be perpendicular, right? It says that there is a walkway that connects the bike path to the lighthouse, and it's 400 yards. So it can't be the direct distance. There's no way the walkway could be here and be 400, because the lighthouse is only 200 yards away. So it must be at an angle for it to be so much longer. So the walkway from the bike path to the lighthouse is 400 yards. Okay, so this is the given information. I'm going to label, they want us to find the acute angle between the bike path and the walkway. So that's this angle right here. That's the unknown. That's what we're looking for here. I'm going to call it theta. Okay, so from theta, this is the opposite and the hypotenuse and the adjacent. What trig function am I going to use to solve for theta here? Sine, because I know opposite and hypotenuse. I can't use adjacent because the angle is already unknown. I can't have two unknown pieces, only one unknown. So I have to use the sides that are given. So that's sine of theta equals 200 over 400. Now my missing piece is not the numerator, it's the angle. What do I do to solve for the angle? Do inverse trig. So inverse sine of 200 over 400. Now 200 over 400 can reduce, can't it? What does that reduce to? You could reduce it multiple times, lots of different things, but all the way down, if it's completely reduced, it's 1/2, 1 over 2. Okay. Before I plug this in the calculator, I want to see if y'all remember something though. So the relationship between this hypotenuse and this leg, look at those numbers, 200 to 400. What's that relationship? The leg is half the hypotenuse, or the hypotenuse is double that leg, right? Do y'all remember any right triangles where the hypotenuse is twice as long as one of the legs? It's not isosceles. Isosceles is a special right triangle. That's a 45, 45, 90 is an isosceles. What was your other special right triangle?
30, 60.
30, 60, 90. In a 30, 60, 90, the shortest leg, the one across from the 30, okay, we called x, and the hypotenuse was 2x. It was double. So if this is the short leg, because the hypotenuse is double it, that means this angle must be 30 degrees. So if you remembered your special right triangles, you would be able to answer this question without a calculator. If you didn't, it's all right. You can type that in, or you can type it in with 1/2 or any version, any reduction of that, as long as it's a 1/2 ratio, 1 to 2 ratio. It comes out to exactly 30 degrees. Okay, so I actually do want to add that up here on the front at the top, there's some blank space here. So I want to just add those special right triangles as a quick refresher. So we said 30, 60, 90, and 45, 45, 90. Those were your two special right triangles. We said for a 30, 60, 90, the short leg, the one across from the 30, because remember the shortest side is across from the smallest angle. So the short leg we call x. The hypotenuse is double that, so it's 2x. And then the long leg is that short leg times square root of 3. So x times square root of 3. So if you know one of the sides of a special right triangle, you can find the other two if you know these ratios. Okay. In a 45, 45, 90, what does that mean about these sides? Yeah, they're congruent. So we called them both x. So if you know the leg of a isosceles right triangle, do y'all remember what the hypotenuse is in comparison?
2x.
Not 2x. X square root of 2. So it had a 2 in it with the x, but it's root 2. Okay. So if you remember those ratios, and we'll review these ratios again in the next unit, because we're going to need to help you understand where some points are coming from. We'll be using these special right triangles, so we'll be reviewing these again next unit. But I just wanted to put it here as a quick recap from geometry. It just saves you some time. Sometimes if you know those ratios, you can sometimes quickly recognize a relationship and know the answer without having to set up your trig and do calculations if you just see the relationship. All right, so back to the last example here. It says find the length of a skateboard ramp if it's 4 feet off the ground at its highest point and makes an 18.4 degree angle with the ground. So find the length of the skateboard ramp. What part of this triangle would be the skateboard ramp? Yeah, the slanted part, the hypotenuse. Wouldn't be too exhilarating to just skateboard along the flat ground, right? I mean, it's still fun, but definitely not a ramp. So the ramp is at an incline. Okay, it says the highest point of the ramp is 4 feet from the ground. So this is a distance of 4. Okay, and then it says that the angle that the ramp makes with the ground is 18.4. So the ramp and the ground be here. So from that angle, this is opposite, adjacent, and hypotenuse. And they are asking for the length of the ramp. So they're asking for the hypotenuse, and we're given the opposite. So what trig function should I set up? Sine. So this time I do know the angle again. 18.4. The opposite is 4. This time I don't know the hypotenuse, so that's the denominator. What did we say when the denominator is missing we're going to do? Yeah, these just switch. You divide. So it's 4 divided by sine of 18.4. I go to my calculator. 4 divided by sine of 18.4. Or was it 18.2 or 18.4? Okay. Okay, what would that be to the thousandths? 672. That 3 does not round the 2 up. So 12.672. What are the units? And what is this the length of? What did we say this one represented? That's the length of the ramp, the length of the skateboard ramp. Feel okay about these application problems? All right, so the math is the same as what we were doing the past few days, okay? You've got to know your SOHCAHTOA ratios. You've got to label your triangle, opposite, adjacent, and hypotenuse, and figure out what trig function should you be using to solve, what piece is missing, and going from there. The difference is the picture's not given to you already labeled. You have to do some interpreting of the situation, of the real world problem, to figure out what goes where and what is it exactly that I'm looking for. Okay. Trig is right triangle trig is extremely useful in the real world. Finding angles. My husband literally last week sent me a message, and he sent me a text. He's like, can you tell me find this angle for me? Because he didn't have time to sit down and do the math. He's was building some cabinets, some cabinetry, like different corners and different things. And so it was a trig problem. Like trig is used often, especially in things like architecture and building and construction and stuff like that. So you'll get some practice on these with some word problems tomorrow in class. But for today, with what's left of class, I want you to go back and check the worksheet you got yesterday from the sub. Check it against the key online. Make sure that you had those, you did that correctly. Fix your mistakes if you got some wrong. Remember, you're keeping that with your notes. Okay, and then you can go in and finish your Delta math. It's due by midnight tomorrow night, but you do have some class time, so you can get some more of that done now.